Good evening, students. Am I audible? The screen is visible.
Yes, ma'am.
Any doubt in yesterday's class portions? Am I audible or not?
Yes, ma'am. Yeah.
Any doubt in quick sort binary search? Shall we move to the next topic? Yesterday we were discussing two algorithmic techniques. One is brute force approach. Another one is divide and conquer technique. Brute force approach is a general common logic which is used in solving most of the problems like selection sort, insertion sort, bubble sort, linear search. We are using the brute force approach. It's an iterative approach, recursive approach. We can find out the solution in a recursive manner, but compared to the other advanced techniques, its efficiency is not up to the mark. Screen is visible.
Yes, ma'am.
Any doubt in quick sort using divide and conquer approach? The best examples are we are solving the binary search by dividing the given list of n numbers into n by 2, n by 2, and the logic used in merge sort, quick sort is divide and conquer approach. Yesterday we were discussing about quick sort. Any doubt in quick sort? Have you tried the program? So in quick sort we are using the partitioning algorithm. Then we are calling the recursive algorithm. Say here we are taking a pivot element. With respect to the pivot element only, the partitioning is performed. Say for example, to understand the concept well, say we'll take a list of 6 numbers. The given input numbers are 12, 14, 12, 16, 13, 11, and 15. This from the given input array, we will take the first number 14 as the pivot element, and with respect to the pivot element, we need to rearrange the numbers which are less than pivot in one side, the numbers which are greater than pivot in another n by 2 n by 2 array. So here we are taking 14 as the pivot element. We will take the pivot element. Then we will compare the pivot with the next number. Here 12 is the smaller number than pivot. We will keep it in the elements less than the pivot 14 this side. 12 comes this side. Again 14 is compared with 16. 16 is greater, so the elements greater than pivot 14 will come this side during the first partition. Again 14 is compared with 13. 13 is small, so that comes here. 14 is compared with 11. 11 is small, so that comes here. 14 is compared with 15. 15 is greater than the pivot element 14, so 15 is placed this side. So during the first iteration, we are making the sub problems with respect to the pivot element 14, which are less than pivot, and the numbers which are greater than pivot. Then again from again we will call the, we need to call for the partition with respect to the pivot, and we will call the quick sort with respect to the pivot once again, and quick sort with respect to the pivot numbers greater than pivot another time. So as per the pseudocode, you can easily understand. We'll call the quick sort for the given list of n numbers with the p is the zero index, r is the the list of numbers, the size of the array, that is the maximum index. We will check whether the p is less than r, that is zeroth index is greater than the list of n numbers, that is final index. P is the zeroth index, n r is the index n, 0 to n minus 1. When 0 is less and n minus 1 is greater, we will repeat the process. We will call the same quicksort. Will with respect to the pivot q, we will call for the partitioning algorithm. In partitioning algorithm, with respect to the pivot, we are partitioning the, we are separating the numbers which are less than pivot and the numbers which are greater than pivot. Again, we are calling quicksort with the numbers less than pivot and with the numbers greater than pivot. So this process is recursively repeated until we sort all the elements. Again, here we are taking 12 as pivot. The number greater than 12 is 13 compared with 13. 13 is greater. Elements greater than pivot 12, and 12 is compared with 11. 11 is small, so the element less than pivot 12 is 11. So again, here now it is sorted. Here it is also again sorted, and the pivot also there. Now we can say the numbers which are less than pivot, the pivot element, and the numbers which are greater than pivot. So now this particular subarray is sorted. The same way this side also, with respect to pivot, the numbers less than pivot, greater than pivot. Again the two subarrays, numbers less than pivot, greater than pivot. Now the complete list is sorted. So any doubt with respect to the quicksort algorithm and the pseudocode program? Have you tried? Have you executed the program? Say now we will check how the program is, how we can execute the program using the compiler. Already we saw the program now. So in yesterday's class itself, we discussed the quick sort. So the program is given, the main program and the quick sort algorithm. We'll check whether the program is working properly or not. Have you tried, checked the in the program and check the answer? The screen is visible.
Yes, ma'am.
What you are seeing? So we are taking the quicksort algorithm. We written the swap function separate, partitioning algorithm separate. Then quicksort function. Quicksort in the main program. We are passing the constant array of 10 numbers. We are taking the numbers as 2, 6, 4, 10, 8, 1, 9, 5, 3, 7. We are calling the quicksort function with the array and size of the array. Then we are taking the array in the sorted form. Have you tried the program, the execution? So the given input is array of 2, 6, 4, 10. So we are getting the sorted array. So there are different, we can use any logic. So we have the partitioning algorithm, including namespace std, partitioning algorithm, low and high. Then we have the quicksort function, array, low and high values. With the main program, we are taking the constant values. Now if you run the program, you are getting the output. Then try the program in C also. The programming statements will differ. And if you take the time complexity of quicksort, in best case, it is n log n, average case, theta of n log n, and in worst case, order of n square. We already discussed the advantages and disadvantages. So, any doubt? Have you tried any animations? How we can say, for example, for your understanding purpose, we are taking an array of list of numbers.
Now, let us go one
We
by
will take the pivot as first number.
I have the element 9. Since 9 is greater than 4, I will keep it on the right side. Forward, I have the element 2. Since 2 is smaller than 4, it should go on the left. Moving forward, I have the element 5. Since 5 is greater than 4, I will place it on the right. Now, note that it does not matter how many elements you have on the left or right. Just start placing elements one after the other. So, place 5, I would just take 5 and I would put it right next to number 9. Moving ahead, I have the number 7. Again, 7 is greater than 4, so it should go on the right. Moving on, I have the element 1. Since 1 is smaller than 4, it should go on the left side. Next, we have the number 6. Since 6 is larger, I move it on the right. Going ahead, I encounter the number 8. 8 is also larger than 4, so it moves on the right. And the last element 3 is again smaller than 4, so it would come towards the left. So this completes one iteration of the quick sort. And you can see that after one iteration, I have segregated the elements into two halves, or I have partitioned the elements into two halves. On the left, I have all the elements smaller than 4, and on the right, I have all the elements larger than 4. You can also say that I have divided.
So got the idea? We are taking the pivot element with respect to the
The
pivot.
problem into two halves.
So the screen is visible. You got the idea? How you are partitioning and how you are sorting. Any doubt in quick sort? Any doubt in quick sort? The logic and the program. So if you take the analysis part, already we discussed the analysis. The runtime complexity of quick sort and binary search. What is the runtime best case runtime complexity?
We go and log in.
In worst case, what is the complexity?
Big O n square.
It is order of n square. Okay, any doubts so far with respect to the topics what we discussed? Any doubt? This unit 2 topics. Okay, go through the topics. If you have any doubt, ask me in the next class. Okay, our next topic is stack. What is stack? Can anybody explain what is stack? Stack is an user-defined data structure. It's lost in first out data structure. Say for example, if you the best examples in real life, what we are using as stack form means if you are ordering the coins, so some 10 coins or 20 coins, so it is a stack of coins. The same way, if you are arranging the books in an order, it is called stack of books. So if you want to take access some book properly, you have to remove the books above the particular book, then only we can take the corresponding book. In the same way, if you take the computer stack, it is nothing but the memory space allotted in the inside the computer to store the values, especially while evaluating the expressions or while performing the task, iterating statements or mathematical, arithmetical, logical operations. So the stack will be a collection memory is allotted with one way. So a continuous memory of 0 to n will be allocated. Some label will be given. We can push the elements and we can pop the elements. So in general, the stack is an ordered collection of data elements into which new elements may be inserted, from which elements may be deleted at one end called the top of the stack. So addition and deletion of elements into the stack can be performed only with the one end called top. So the stack is having a variable called top. Both addition and deletion of elements into the stack, the memory location, is performed through the top point. A stack is a lost in first out data structure. Lost in first out data structure. The insertion operation is referred as push. If you are adding elements into the stack, that is called push. And if you are deleting the elements from the stack, that is called pop. So they are the functions associated with the stack. The most accessible element in the stack is the element at the position top. So the top is the pointer, or we can say it is the variable. It points to the current location where we can push or where we can delete from the stack. The stack must be created as empty. While creating the stack will be empty. Whenever an element is pushed into the stack, it must be checked whether the stack is full or not. So if the stack is already full, we cannot add any more elements. If the stack is empty, we cannot delete elements. It's like a bucket, or we can say it's a bucket. If it is already full, it will overflow. If there is nothing in the bucket or no water in the bucket, it is empty. Whenever an element is popped from the stack, it must be checked whether the stack is empty or not. If we want to delete something from the stack, we have to check whether the stack is empty. If the stack is empty, we cannot perform the delete process. Okay, before performing deletion, we have to check whether the stack is empty or not. If the stack is empty, we cannot delete. If it is full, we cannot add. We can implement the stack as an abstract data type either with the array or linked list. So as we already discussed in the unit 1, we have some abstract data types associated with all the stack operations. I think while discussing the ADT, we discussed the stack related operations. What are all the things we can do with the stack means? So if you take the abstract data type stack, the stack is an first in last out data structure. We can push an item. Push means it is adding the elements into the stack data structure, and pop means deleting the element from the top of the stack. And peek is used to return the item at the top of the stack without removing it. And if is empty, this particular function is used to check whether the stack is empty or not. So these are all the operations associated with the stack: push operation, pop operation, peek operation, and checking whether the stack is empty or full. And if the stack is empty, the top will point to the 0th position. And if the stack is full, the top pointer will point to the nth position. 0 to, it's like an array, 0 to n memory locations. So 0 to n minus 1 data. Any doubt in the basic concept of what is stack? If you take the function push, what is the logic behind the push function means? So if you take the algorithmic steps, step 1, if top is greater than or equal to max minus 1, then the stack is full. We cannot add because max is the size of the stack. Max minus 1 means 0 to max minus 1 means already the stack is full. We cannot add any more elements. Display the stack overflows. If the condition is satisfied, then it means the stack is overflowing. So the condition to check whether the stack is overflow or underflow is top is greater than or equal to max minus 1 means the stack overflows. Else then top plus plus. So if it is that the stack is not overflowing, we can increment the top pointer. Then we will add the element in the top. Assign stack of top. So stack is your data structure of top points the whatever value you are assigning that will be saved in the top position. Display the elements inserted. So this is the algorithm for push operation. Any doubt? While adding the elements, we have to check whether the stack is full or not. If the stack is already full, whatever we are adding, it will overflow. So the same way, if your mind is full, you cannot learn anything new. So you have to often you have to empty or you have to delete unwanted things. Then only there will be some space for adding or learning new things. The same way, if you take the pop function, pop is the function used to remove the element from the stack. So here, before removing the elements, say for example, if you are going to the bank to withdraw some money or withdraw money from the ATM, what we will do, we'll think what is the balance. If the balance is, the enough balance is there, then only we can able to withdraw. The same way, while withdrawing, we have to check what is the balance. If the balance is minimum balance is not maintained, we cannot able to withdraw. There is enough money, then we can withdraw. The same way while depositing also, there is a depositing limit. Per day you can deposit maximum maybe 4,999. Depends on the customer account. Per day you can deposit this much. In what banks that ATM bank deposit option. If you are going to the bank and if you are depositing, you can deposit limitless. The same way, while deleting the element from the stack, we have to check is there any some element in the stack. If there are elements in the stack, then only we can delete. If the stack is empty, we cannot able to delete. So the condition to check whether the stack is empty or overflow, underflow is top equal to top double equal to minus 1 means the stack is empty. If the stack is not, if the condition is false, if there are some elements, then stack of top is assigned to x and top minus minus. So we are removing the element and reducing the top length and return the x. So this is the function for pop operation. The same way to implement the stack using any doubt in push and pop operations, they are the major operations. Now we will see how we can implement the stack using template. So we are including hash include iostream.h, then including using namespace std, include stdlib.h. So the library functions are added, and we are taking the size of the array. Maximum we are fixing the size maximum maybe 50 or 100, your wish. Then we are taking an class template, a template class t. Then the class stack is declared. Within this class, private variables t type, that is the template type, top dot stk. Top is a variable, stack of 50 and item. So the item which we are going to add into the stack and the top pointer and the size of the stack. Then the constructor function stack, class name is stack, our function name is also stack, it is a constructor function. Then we are defining the push function, pop function and display function. Using template class T, stack of T, stack. From the stack we are initializing a new template, top equal to -1, code to push an item into the stack. So initially we are pointing the top pointer point to the -1. It means it is pointing the 0th location. Top may be pointing to the first memory location. So it is assigned to -1. When we add the element into the, we will increment the top pointer, then we will place the element in the 0th position. Initially the top is pointing -1. Code to push an element into the stack. So for using the template, if top is not max -1, it means the stack is overflow. If the stack is not overflow, then enter an element to be pushed, top plus plus seen item. So the item is received and the top pointer is initially -1. Then we are incrementing to 0th position. So in the 0th position, the first element is stored because the stack is not overflowing. The stack of top, the item is added. Now top is I plus plus means now stack of 0th location, we are storing the item. And the item is pushed successfully. So this is the function for push, performing the push operation. The same way we are performing the operation for pop. Pop means deleting the element from the stack. Before deleting the element from the stack, we have to check whether the stack is underflow or not. If the top pointer points -1, then the stack is empty. If the stack is empty, we cannot delete elements. If the condition is false, then we can take stack of top is assigned to m and top minus minus. So an element is assigned, the top most element is assigned to m and the pointer is pointing to the previous location. So the item is popped out separately. So using the display function, we are displaying the content of the stack. Display if top is not -1, if there are some elements in the array, if the stack is not empty, then for I equal to 0, for I equal to top pointer to I less than -1 until it reaches the 0th location, display the elements. In the main program, within the main program, we are calling menu for stack operations, push, pop, and display. Enter the choice. So your choice is 1 means using switch case statement. 1 means we are calling the push operation. 2 means we are calling the pop operation. 3 means we are calling the display function. 4 means we will exit from the main program. So our main program is here. So then we are getting the choices from the end user. Using switch case statement, we are performing 4 different cases. The default condition is invalid choice. The main program ends here. So this is a switch case. This is one more while loop. So we can iterate, we can repeat the process. We can repeat the process until this is for while loop and this is for main program. Any doubt in the stack operations? Any doubt what is stack? What are all the operations we are performing with stack? The same program you like to see do in C++, we are using templates. Even you can try the program using C programming language also. So in that case, the same operations are same. The screen is visible. Screen is visible.
Yes, ma'am.
Say for example, if you want to implement the stack, you have to write aim, the program to implement stack operations. The algorithm for push is, before pushing, we have to check whether the stack is overflow. Say for example, better we can take the bucket. If the bucket is already full, whatever water you are adding, it will overflow. So before pushing, we have to check whether the stack is already full or not. So if it is already full, we cannot add any more elements. Okay. So before push, we have to check whether the stack is overflow. The condition to check the overflow is front top is pointing max minus 1. Size of the stack is n because it starts from 0 to n minus 1. So the top is pointing n minus 1 means stack overflow. Stack is overflowing means we cannot push. If the condition is false, then we increment the top and add the element in the stack of array front item to be pushed. If you take the pop operation, so that is the push operation. So in pop operation, we have to check before deleting the element from the stack, we have to check whether the stack is empty or not. If the stack is empty, if it is underflow, we cannot delete elements. If the condition is false, then top minus minus or front minus minus, and the element will be popped out. And display means if there are some elements in the stack, then we can display. We will check whether the top is pointing minus 1. If it is pointing the 0th location, then the stack is empty. If the stack is empty, we cannot, nothing is there in the stack to display. So before display, we have to check whether the stack is empty. If the condition is false, then for I equal to front from top to 0, that is from the n minus 1 to 0 location, we can display all the display of stack array of I. We can display all the elements. So if you take the source code, we are including stdio.h, conio.h, process.h. stdio.h is for input output operations. Conio.h is for console input output operations like ch, scanf, printf, and process.h is for the various processes, stack related operations. So we are including a stack of 10. The size of the array is 10. Item, the item what we are going to push or pop, and the top pointer which is pointing the 0th location, and the index variable I for loop, I loop, and ch is the character that stores the position ch, all are integer type. Then character cho, so it is echoing the values. Then we are declaring 3 functions. In the declaration part above main, we are declaring 3 functions. We are going to perform 3 operations: push, pop, and display. So within the main program, we are getting the array elements. It will display the echo yes or no, then the menu, push, pop, all those things. We are getting the choice using switch case. We are performing push, pop, exit, and the operations are push operation, pop operation, display operation. So the meeting will end in another 1 minute. All of you join back. So any doubt in this program? All of you join back.